In this video, we're going to be going over how we can actually use our trigonometric ratios to help us find a missing side of a triangle. So recall, these are what we did in the trigonometric ratios lesson, where we're introduced to these three ratios, and you guys were given the shortcut of SOHCAHTOA to help you remember these ratios. So alert, your calculator, which you're going to need one, defaults to what we call radian mode. Now, radian mode is something that affects your answers when you're doing trig problems. So what you need to do every time you start doing these problems, like if you're in school and then you go home and you're doing your homework, you want to make sure you always check this when you're starting to do a set of problems. So what you do is you need to make sure you go to, if you click this mode button, if you have your graphing calculator should look something like this, where you have these similar buttons. You should have a mode button. You click mode and you scroll down and you can see this calculator is defaulted to radian. That is very bad. So you need to bring this arrow over. You need to hit enter on degree, and then you can usually either click clear. Yeah, clear works, so we can click clear. And again, double check every single time that your calculator is on degree mode. Alright, so this is a checklist that you guys have to find a side of a triangle using our trigonometric ratio. So our first step was what we just did. We want to make sure our calculator is in degree mode. Second step, you guys know this, if there's no picture, we have to draw one. And we should always label what we're trying to solve for as x in our diagram, just so that we have a visual representation of what's going on. We want to also identify our reference angle. And then from our reference angle, we also want to label, just like we did in the trigonometric ratios lesson, we want to label the opposite, the adjacent, and the hypotenuse sides of our triangle. Identify the ratio that we're going to use, and then we're going to substitute our numbers in and actually solve. So in the last lesson from the video, we didn't have any numbers. We were just putting the segments in. In this lesson, we will have some numbers, and we will be using our calculator, so you should have that handy. So we're just going to get right into an example. We're going to follow the checklist that you guys have so that you can see how to utilize it for each question. Now, there's two different types of examples, and I'll explain the different types of examples to you as we work a little bit through. So first step of the checklist, we have already done. Our calculator is in degree mode, so we are good. And to me, it seems like we have a picture, so we're also good there. So let's just read the problem first. So as shown in the diagram below, the angle of elevation from a point on the ground to the top of a tree is 34 degrees. Then it says, if the point is 20 feet from the base of the tree, what is the height of the tree to the nearest tenth of a foot? So we have a diagram, but we got to fill some stuff in here. So we got to make sure we're looking for the right keywords, right? So the first thing that's standing out to me is that we want the height of the tree. Now, height is always something that's measured vertically. And before I even put that in, we have a fancy diagram here with an image of an actual tree drawn. I'm redrawing this triangle. It's easier for me to see it just as a triangle without all the graphics in there. So I would recommend that you guys do the same. So as you're working on your notes, you should have this redrawn triangle in there. Now the height of the tree, again, we're going fully vertical with that one. So that is going to be our x. Now it says a point on the ground. This point on the ground is 20 feet from the base of the tree. So the base of the tree is here. This point on the ground is over here. That 20 is going to go in this bottom region right here. Now we want the height of the tree. Okay, so we've already accounted for that. So now we need to identify our reference angle. Well, the reference angle is the given angle that we have. They give us this 34 degrees. We're going to use it. So our reference angle is the 34 degree angle. Now, step number 4, from our reference angle, we want to label the opposite, adjacent, and hypotenuse sides. So opposite is straight across from our reference angle. So this is our opposite side, right? Our hypotenuse side we can do in green. If our right angle is here, our hypotenuse is going to be here, which also then means that our adjacent side is this side right here. All right, now we got to figure out the trig function we're using, so I kind of went against my rule. Before I start every question, I write SOHCAHTOA. Now let's figure out the information that we have. Now what's standing out to me is that we labeled this as the hypotenuse, yes, but there's no value and there's no variable written in there, so I'm crossing that out. I don't need the hypotenuse. What I need is the adjacent side and the hypotenuse side. So I need the A and the O. Now the only trig functions with an A and an O, not sine, not cosine, but tangent. So what I do here is I'll rewrite my function. Tangent of theta equals opposite over adjacent before I even fill any numbers in. Now let's substitute. So remember, theta is just our angle, our reference angle that we're using. So tangent of 34 equals our opposite side, which is x, over our adjacent side, which is 20. Now, once you get here, this is just algebra. So you're going to do your opposite operations in order to get x alone to solve for x, right? So here we have this divided by 20. So I'm going to multiply by 20 on both sides. What I get is 20 times tangent of 34 equals x. Now, once we have x alone, that is our sign to now run to the calculator. So in your calculator, make sure you're familiarizing yourself with where these buttons are. So we have sine right here, cosine right here, and tangent right here. So once we have x alone, we're just going to put everything on the left side of the equation into our calculator. So 20 times tangent of 34 degrees. And we want to make sure we close that parentheses. And then we're going to hit enter. So we get this number. And again, look at what we want to round to. Because we have a lot of decimals, we're rounding to the nearest tenth of a foot. So that number that we get 13.5, that would round to, equals x. Now I just want to show you guys something. Let's say that our calculator was in radian mode. Let's enter that same thing in here. I'm just going to scroll up and hit enter to enter that same thing in here. If we do that, look at the difference between those two answers. Look at that. If you add radian mode, you would get negative 12.46, which doesn't even make sense because we can't have a negative height, right? But again, making sure your calculator is in degree mode is super, super, super important. All right, so in this example, what we've seen is that the x, our missing value, was in the numerator of our ratio, right? And in this case, we just multiplied by our denominator, and then we were able to go to our calculator. In this next example, we're going to have this variable in the denominator of our ratio, so that the process changes just a little bit here. But let's follow our checklist. So our calculator, we know it's in degree mode. We have a picture, but again, what I'm doing is we'll go under this time. I'm going to redraw this triangle. Maybe let's redraw it a little bit bigger. We have our right angle, and we even have our numbers and our variable written in for us, which is good. Okay, and I know that my step 3, my reference angle, identifying our reference angle, is this 16.5 degree angle that's given to us right here. Now, going back to our checklist, make sure you guys are following along, reading the checklist on your end as well. We want to, oh, I went against my rule again. Forgot to write SOHCAHTOA. Okay, good. All right, step number 4, from our reference angle, which is this 16.5 degrees, label the opposite, adjacent, and hypotenuse sides. So straight across, my reference angle is my opposite. I know the side right across from my right angle is the hypotenuse, which leaves this side to be the adjacent side. Now, let's identify the trig ratio we're using. So, again, what is standing out to me here is that we've written this in. However, there's no number or variable written in for it. It's not involved at all, so I'm not even looking at that. What we need, though, we do need the opposite side, and we do need the hypotenuse side. So the only trig function that uses opposite and hypotenuse is sine. So we're going to write that out. So sine of theta equals opposite over hypotenuse. And now I'm going to substitute. So sine, my reference angle is 16.5, equals, our opposite side is 8, over our hypotenuse, which is x. Now you can see the difference, because now our denominator is not a number. Our denominator is a variable. The same idea follows, though. Like in the example before, if you look back on that work, we multiplied by that 20 that was in the denominator, right? It's the same idea here. We still need to multiply by this denominator. So we're going to multiply by x on both sides. Now what's happening on the left is we're going to have x times sine of 16.5 equals, now what's happening when we multiply by this denominator, they are simplifying out. So what we're left with is this 8, which is what we want, right? But now there's one extra step here. Because before, once we multiply by that denominator, we were able to go to the calculator. But here we cannot, because x is not by itself yet. X is right now, it's connected to this sine of 16.5. Now, what I want you guys to realize is that if you went in your calculator and you put sine of 16.5, it's just a number, right? So we can divide by that number. So what we're going to do here is we are going to divide both sides because we want x alone. So x, we're going to divide by sine of 16.5 on both sides of our equation. And what's happening here is when we divide, they're simplifying out. So we're left with x equals 8 divided by sine of 16.5. Now again, this idea still follows, right? So we're on step 6 where we've substituted. Step 7 was solve for our variable, which we just did. Once you have your variable alone, then you can go to your calculator, right? So we have x alone, so be careful how you write this in. In this case, it's a simple fraction, but it might be a more complex fraction, so I like to be precise all of the time. So I do 8 divided by, I'll put parentheses to make sure that everything is staying in the denominator. So sine of 16.5, and then we have to close those parentheses, and you will get this number. You want to also look at what we're rounding for. In this case, we're rounding to the nearest tenth. So x is going to be equal to 28.2 inches. Don't forget our units. I think on the last question I forgot to write the units in. And we always, right, we're always precise. We always box our answers. Now, in this question, you probably could have just done this, 8 divided by sine of 65 without the extra parentheses and got the same thing. Oh, sine of 16, sorry, 8 sine of 16.5. My bad. You get the, I keep doing the same thing, 8 divided by sine of 16.5. There we go. You do get the same answer. So you don't need that extra set of parentheses. I like to be precise, but it is totally up to you. But yeah, make sure you guys are writing SOHCAHTOA in the beginning of every problem, unlike I did, so that you can help remember the trig functions and kind of use that as a process of elimination after labeling like we did in all these questions.